Details. Very often the key to improving customer satisfaction lies in the way we handle the details. A flawless finish is something that Buick customers have come to expect over the years. Paying attention to detail provides the luster and shine that will keep our customers happy. Buick has gone to great lengths to ensure that cars leaving our assembly plants have the highest quality paint finish possible. Hi, I'm Chris Wolf. Welcome to Service Bay Chat. Even the simple things like the way we prep our customers' cars for delivery can make a big difference. Although we've achieved very high quality paint finishes on our new Buicks, we continue to receive complaints about fine scratches and swirl marks in the clear coat. Today's base coat clear coat paint finishes are very different from traditional finishes of years past.
Any swirl marks?
No, all the vehicles are looking pretty good. I haven't noticed any swirl marks at all.
Good. Hi, Letty.
Hi, Chris.
Letty Larkin, Customer Satisfaction Manager at Buick City, is here to provide tips on preparing new Buicks for delivery.
Typically, new vehicles arriving at your dealership should need nothing more than a simple wash to bring out the luster of the finish. It's only when you see swirl marks or other flaws that you need to take action. Before we highlight a simple way to correct these types of problems, let's go over a few things that should be avoided. Never wash vehicles in direct sunlight. This will prevent soaps and detergents from drying on the finish and reduce spotting. Avoid abrasive brushes and brooms that are used in some car washes. The nylon or plastic bristles of these brooms and brushes can produce fine scratches in the surface of the finish. So always use brushless car washes or a soft sponge when washing the vehicle. Never use a wax or silicone-type products on the finish in an attempt to hide swirl marks. These products may temporarily hide swirl marks, but once the vehicle is washed several times, they will reappear. When dealing with other finish problems, such as rail dust and environmental damage, perform the repair outline in current bulletins. It is also important to use approved products for these procedures. Service Bulletin 93-10-22 contains the proper procedures and a complete list of the recommended products to do the job right.
Looks like we have a swirl mark right here.
When dealing with finish problems, it's a good idea to approach them with a less is best attitude. In other words, start with the simplest solution to the problem and work from there. You wouldn't begin fixing a swirl mark like this by wet sanding. If you need to use the wheel for polishing, keep it between 1,500 and 2,000 RPMs. This is important because working at faster speeds will cause the compound to heat up too fast. Always inspect the finish under suitable lighting. Normal shop lighting is usually not bright enough for you to detect flaws, so either bring the car outside into the sunlight or use a halogen lamp. If you can still see swirl marks, repeat the procedure.
Thanks, Letty. In order to fulfill our mission of exceeding customer expectations, we must do everything possible to ensure our finishes are world-class. While much of this information may seem very basic, the key to improving customer satisfaction lies in the way we handle the details. Oh, one more thing. In this month's know-how, Ian Doran, Resident Service Engineer, will answer your questions on automatic climate control systems featured in our Park Avenue and LeSabre models.
Okay, I understand what the customer's complaint is, but I have to tell you, that is how the system is supposed to work. Exactly. When the system is in auto and in cold weather, the blower motor will not operate until coolant temperature reaches 100 degrees Fahrenheit. No problem. I'll talk to you later. You wouldn't believe the number of calls we get on this system. A lot of them are just like this call. The customer complains that something doesn't seem right with the system. Oftentimes it turns out the system is operating just as it was designed. That's why we sent out a questionnaire asking for your most commonly asked questions regarding the CJ2 system found on Park Avenue and LeSabre models. Before we get to the questions, let me provide some basic information for those of you not familiar with this system. I'll start by identifying the system components and explaining how they work. Let's start with a programmer. It's the brains of the system. The programmer receives input from the driver and passenger control heads, the right and left solar sensors, the in-vehicle temperature sensor, the ambient sensor, and the powertrain control module. A microprocessor in the programmer processes signals from these inputs and then sends a voltage signal to the blower module to adjust blower motor speed, open the vacuum actuated valves that direct air to the desired locations, or sends a voltage signal to the driver and passenger air mix valves to adjust the temperature setting. There is a difference in programmer design between 1991 and 92 model years. The 1991 programmers have two actuators inside of the plastic case. The upper actuator controls the passenger air mix valve, while the lower actuator controls the driver air mix valve. Both actuators contain feedback potentiometers, which inform the programmer of valve positions. 1992 and 93 programmers have one actuator inside the housing. It controls the driver air mix valve. A remote actuator, or flat pack motor, operates the passenger air mix valve. Like their 1991 counterparts, both actuators contain feedback potentiometers that inform the programmer of valve position. As you can see, 1991 programmers are not interchangeable with 92 or 3 programmer models. The heater and air conditioning control assembly allows the driver to communicate with the system. The controller is only a link into the system. Remember, the programmer is the brain of the system. This controller allows a technician to access the system's onboard diagnostic feature that we'll be talking about later. Back to our questions here. The first comes from Tom Heinz of Armstrong Buick in Milwaukee. Tom wanted to know what the acceptable side-to-side temperature difference should be when the system is in the auto mode. Well, the passenger side control head allows the passenger to change the temperature in the passenger side of the vehicle. The maximum side-to-side temperature difference is approximately 20 to 25 degrees exiting the outlets. However, this translates to about a 5-degree temperature difference once the passenger side air is blended with the driver's side air. The in-vehicle temperature sensor is a thermistor that's resistance varies inversely with the temperature. As this diagram shows, when the interior air temperature increases, resistance decreases. When the interior air temperature decreases, resistance increases. The ambient temperature sensor is also a thermistor that's resistance value varies inversely with temperature. This sensor is mounted to the core support at the front of the vehicle. The mounting position on the core support varies from 1991 to 1993. There are two solar sensors mounted to the right and the left of the upper dash trim panel. These sensors are light-sensitive photodiodes. They determine the sun's heat load on the driver and passenger side of the vehicle. The programmer compares the solar values to the in-vehicle temperature sensor reading to determine how much cooling is required. The blower control module is a solid-state device that operates the blower motor. Its output voltage varies between 0 volts when the blower is off to 12 volts or maximum blower output. To determine the appropriate voltage output, it monitors a voltage signal between 2 and 8 volts from the programmer. The module then amplifies the signal voltage and applies voltage directly to the blower motor. So blower speed is proportional to input voltage received from the programmer. Jim Culler of Joyce Buick in Mansfield, Ohio had a question regarding blower delay. Jim wanted to know why the blower comes on so soon after the vehicle is started in auto mode on cold mornings. That's a good one. There is a blower delay built into the system that delays blower startup in cold temperatures. This delay prevents blower operation until coolant temperature reaches 100 degrees Fahrenheit. However, this blower delay will be overridden on 91 and early 92 models unless the auto climate control and auto blower buttons are on at startup. If this mode is selected after the vehicle is started, the blower delay will not become active again. The blower curve was changed in mid-1992. This graph illustrates the bar counts that can be seen on the controller's display as compared to the engine coolant temperature. When the coolant reaches 100 degrees Fahrenheit on 1991 through mid-1992 models, the system displays 3 bars and the blower increases to 64 counts. As the coolant begins to increase in temperature, the blower speed and bars on the display will increase rapidly. As the coolant temperature increases on mid-1992 through 1993 models, the blower will increase in speed gradually. Once a selected temperature has been reached, the blower speed will gradually drop. Here's another question from Jim Culler. Jim asked, why isn't there a bi-level setting on the control head? Back when we were designing the system, a decision was made not to include a bi-level button on the control head. We figured that since the system would run through a bi-level mode in auto, it really wasn't necessary. A number of customers have asked for a bi-level button, so we will add one to the control head in the next couple of years. The air inlet assembly contains an air recirculation valve that is opened and closed by a vacuum actuator on command from the programmer. This allows outside air to be drawn into and circulated throughout the system. Even when the air recirculation valve is in its closed position, it still allows a 10% airflow into the system to maintain constant pressure inside of the vehicle. Oftentimes, this is why customers complain of smelling fumes or a diesel odor while passing a truck, even if the system is off. The modular duct assembly has 2 vacuum-operated actuators that operate internal doors. These doors determine the mode by directing air towards the windshield, the floor, the dash vents, or any combination. When heater is pressed, the heater and AC actuators move the mode valves to direct air out the heater outlets. However, about 5% of the air will bleed off towards the defroster. When the defog button is pressed, the heater and AC actuators will position the mode valves between the heat and defrost position. This will force 50% of the air out of the defroster outlets and 50% of the air out of the lower outlets. When the defrost button is pressed, the heater and AC actuators will move the mode valves to direct air towards the defroster outlets. About 5% of the air will bleed off toward the lower outlets. Before we talk about the auto mode, let me answer another question from Tom Heinz. Tom says that customers often comment that the auto mode works fine in spring and summer, but as soon as winter hits, very little air exits the instrument panel or defroster outlets. Most of the air exits at the lower outlet. Well, that's exactly how the system is supposed to work. Let's talk about the auto mode, and we'll answer that question in a minute. You see, when the auto button is pressed, the programmer runs through a complex set of formulas to determine optimal door positions. It primarily looks at the set temperature and the ambient temperature, but it also factors in coolant temperature, in-vehicle temperature, and the solar sensors. When the vehicle is in the auto mode in cold winter temperatures, air will exit the outlets in the following order: the lower heater, both defroster and lower heater outlets, or defog, and then instrument panel and lower outlets, or bi-level. When the temperatures are cool, such as in spring, air will exit the outlets in the same order. But since the air is not as cold, air will exit these outlets for a shorter amount of time. However, when bi-level is reached, air exiting the instrument panel outlets will be measurably cooler than air exiting the floor outlets. This top to bottom temperature variation is calibrated into the system. When the system is in auto mode and in warm temperatures, such as a summer day, air will exit the outlets in the following order: the instrument panel outlets with the recirculation valve closed, then the recirculation valve opens and air exits at the lower heater and instrument panel outlets or bi-level. In hot temperatures, such as the desert, the system will run through the modes in the same order. However, air will exit each of these outlets for a longer period of time, or the recirculation door will remain closed all the time. When the system is in auto, or the auto blower button is pressed, the programmer varies the speed of the blower automatically. As the in-vehicle temperature, coolant temperature, and solar sensor values change, the programmer calculates appropriate blower speed and signals the blower control module accordingly. The auto blower feature can be overridden by pressing either the high or the low blower buttons. Here's another question from Tom Heinz of Armstrong Buick. Tom wanted some more information on the serial data line failure code 38. Let's go over this programmer chart, and we'll get to that question in a minute. The 91.5 release was the start of production. It will be in about 90% of the 1991 models. Late in the 1991 model year, we moved the ambient temperature sensor from the upper part of the radiator support to the middle. The 91.6 release compensated for this change. We also recalibrated the blower curve on this model. This will allow the blower to come off of high sooner when the system is in auto mode. There was also an ambient temperature update added to this release. In the previous release, the programmer updated the ambient temperature every 6 hours. The 91.6 release now updates the ambient temperature every 2 hours. If you're working on a vehicle with the previous problems and it has the 91.5 release, replace it with the 91.6 release. However, the 91.6 contains the latest calibration changes and is the final release for the 1991 model year. The 92.1 model is the start of the 1992 production. The 92.2 model was released to prevent the setting of a serial data line failure code 38 that Tom asked about earlier. We had several instances where a customer would turn their vehicle on, then shut it off and turn it back on again. This rapid ignition cycle would set the code 38. Upgrade to the 92.9 programmer if you're working on a vehicle with this problem. The 92.3 programmer was released to correct the setting of driver and passenger air mix actuator codes 40 and 41. When the system goes into its startup routine, the driver and passenger doors are cycled to the full hot, then full cold position. With this problem, the doors were pulled too tight on either the cold or hot end, causing the code to set. This programmer should also be replaced with a 92.9 release. There were some changes made to the heater evaporator case in February of 1992. The 92.4 programmer was calibrated for these hardware changes. It also has the new blower curve calibration that we talked about earlier. The new blower curve increases blower speed gradually after the engine coolant reaches 100 degrees Fahrenheit. The ambient correction value was updated in the 92.5 programmers. This was done to correct complaints of extremely hot air being blown out of the outlets when the heater was on and the ambient temperature was below -24 degrees Fahrenheit. This usually only happens in extremely cold climates. The 92.9 release was the final calibration for the 1992 model year. It was released to further widen the window to correct the problem we had with the setting of code 40 and 41 that we talked about on the 92.3 models. It also contains the other service fixes for the 1992 model year. The 93.2 programmer was the first release of the 1993 model year, and it has the same calibration level as the 92.5 model. Although the calibration level may be the same, don't replace 92 programmers with 1993 models. They are not interchangeable. The most recent programmer to date is the 93.3 model, which masks the setting of the long-term freon loss code 48. This code was often set when a Tech 1 was used to enter the system diagnostics. This problem was covered in Service Bulletin 93-1-1. This release also has a new routine added that engages a compressor at temperatures above 48 degrees Fahrenheit to correct fogging conditions. Now let's go to the service area and discuss system diagnosis. Hi, Pat.
Hey, Ian, how you doing?
Good.
Good.
This is Pat Smith, our service technician. He'll demonstrate the system's onboard diagnostic feature along with some repairs. Pat, why don't you take it from here?
Thanks, Ian. Based on our experience with the system, the most critical point of system diagnosis is verifying the customer's complaint. Oftentimes, complaints with this system are due to a lack of understanding of normal system operations. So, before entering the onboard diagnostics, always verify the customer's complaints. The onboard diagnostic feature can be used to display diagnostic trouble codes and system data parameters, clear diagnostic trouble codes, and to command some programmer's outputs. Now, let's enter the onboard diagnostics.
Turn the ignition switch to run and press the off and warm buttons on the controller simultaneously. If a diagnostic trouble code is set, the temperature reading will flash during the first 2 minutes of operation. These codes can be cleared by pressing the low button until 3 degrees Celsius is displayed. At this display, press the high button. These codes are cleared when 1 degree Celsius is displayed. If there aren't any codes stored, 0 should appear on the display. Press the low button once to enter the data list. This displays numbers which represent system components and what parameters they are currently operating under. Simply press the high and low buttons to sort through the list. Another feature the onboard diagnostic system offers is the ability to command the system's outputs. The Know-How Reference Manual contains a chart listing the overrides and the various operating parameters. To enter the override feature, press low after the segment check until 2 degrees Celsius is displayed. Now, press either the high or low button to cycle through the override list. Once the desired override has been reached, press either the warm or cool buttons to change the value of the selected override.
It is also possible to perform these operations using a Tech 1 equipped with the mass storage cartridge.
That's right, Pat. I also want to remind the technicians to use the symptom diagnosis guide provided in the Know-How Reference Manual, in addition to the symptom guides provided in the ESM. Using these guides, along with the onboard diagnostic feature, you can really cut down on your diagnosis time. Well, that covers the system's onboard diagnostic feature. Now let's go over some repairs. Before we start, here's a question from Zach Winters of the Dallas Zone. Zach wants to know why there is such a side-to-side temperature variation when the system is in the auto mode. There are basically two reasons for this. First, the temperature valves may not have been properly adjusted in the assembly plant. And packaging concerns were also a factor contributing to this condition. We are simply limited to what we can do in such a small area under the instrument panel. Well, let's begin with a repair that will take care of these side-to-side temperature differences. We'll begin the procedure by properly adjusting the driver and passenger air mix valve linkages.
Start the vehicle, then select max heat. Then set the passenger side controller to max heat and allow about 45 seconds for the passenger and driver air mix valves to set. Then remove the instrument panel compartment. Now, before removing the linkage, mark the thread position like this. Each thread represents an output temperature change of approximately 10 degrees Fahrenheit. Notice this stop molded into the heater evaporator case. It was added for assembly plant adjustment purposes on 1992 and 1993 models, but we have seen several cases where the crank arm hits the stop before the door is fully closed. When this happens, cool air can enter the system and create a noticeable side-to-side temperature difference. If you notice this condition when adjusting the passenger side valve, simply remove the stop. Remove each of the linkages and reposition them in their cranks, 1 or 2 threads down from the marked position. Both the driver and passenger air mix linkages should be adjusted together. Adjusting only one may result in a more severe temperature difference. Next, start the vehicle, then select max heat. Allow the vehicle to warm up, and then check the temperature differences. If a slight improvement is noted, try readjusting each of the linkages 1 thread further. If this doesn't correct the problem on vehicles built before February 1992, we'll alter the heater evaporator module splitter wall. It's important to remember that this system was designed to have a natural top-to-bottom temperature imbalance of about 30 degrees. So this repair should only be performed in extreme cases. Before going any further, both the driver and passenger air mix actuator linkages should be returned to their original positions. To get to the splitter wall, the remainder of the dash, along with the modular duct, will need to be removed. The next step varies depending on model years. Early 1991 models use a screw to reinforce the splitter wall. Remove this screw and the splitter wall. However, you won't find this screw on vehicles built after mid-1991. On these models, remove the splitter wall by applying firm and steady downward pressure until its weld breaks. Then, using a hot knife or hacksaw, extend a notch on the heater evaporator module to accommodate an additional retention tab in the new splitter wall. You also need to slightly modify the new splitter wall to fit into the heater evaporator module. Use a hacksaw or a hot knife to cut the new splitter wall to match the template provided in the know-how reference manual. Next, remove the programmer heater core access door and the 2 screws holding the core in place. Drill out the temperature baffle heat stakes in the temperature doors using an 11/64 drill bit. Now you're ready to install the new upper and lower baffles. Secure them in place with the push-on retainer washers. When installing these new doors, it's a good idea to apply a silicone grease to the seams where the baffles are attached to the upper temperature valves. This will prevent door whistles. Next, install the new splitter wall by drilling a hole in the side of the heater evaporator module. Then pop rivet it in place. Finish the procedure by reinstalling the air distributor and dash in the vehicle.
Pat, while you're doing that, let me answer another question. This is another one from Jim Culler at Joyce Buick. Jim wanted to know why the air coming out of the lower outlets is so much warmer than the air exiting the instrument panel outlets. Well, generally, air exiting the lower outlets will be about 30 degrees warmer than air exiting the instrument panel outlets. It's usually more comfortable for people when warm air is directed towards their feet. If the air exiting toward the upper half of the cabin was as warm, the vehicle's interior may become uncomfortably stuffy. This next repair will help increase the volume of air exiting the defroster outlets. Some owners of 1991 Park Avenues may complain of poor defroster performance on the driver's side of the windshield. The volume of air exiting the defroster outlet can be increased slightly by removing vanes 2, 4, and 6 from the distributor assembly. As you can see, this is out of a 1993 model and the vanes are already removed. See Bulletin 91 1-5 for more details on this. I want to stress the point that this repair is better for vehicles in warmer climates. Removing these vanes does not increase the flow of air to the windshield enough to make a significant difference in colder climates. We are presently working on a repair that will help vehicles in colder climates.
Another problem that we've encountered is a lack of air exiting the side defoggers when the system is in heater mode. This may be due to improper sealing of the defogger duct to the back of the door pad. There's only 5 to 7 CFM exiting the outlet when the blower is on high, so any leaks from the duct will will reduce defogger air output considerably.
This condition can be corrected by removing the door pad and resealing the defogger duct with an RTV sealant. Install the door pad and check that the instrument panel air outlet lines up with the door pad air inlet.
Then, set the system to Econ and check the air output at the defogger outlet.
The Know-How Reference Manual contains a complete list of repairs and a diagnostic approach that should be used when diagnosing problems with this system. Using this diagnostic approach will ensure that your Buick service customers are more comfortable while driving, regardless of the outside temperature.